Good morning. All right, this is section 3.3 still. We've got a couple more examples to finish up here, and then we'll get into 3.4. I did go ahead and push the homework back to Monday of next week. I think between today and Monday, we should be able to finish 3.4. And even today, you should have enough to at least get started on the 3.4 stuff. So hopefully by Monday, you can finish that up. I think that's all for now. Just keep in mind, probably within the next couple of weeks, we'll be having the next test. I think probably late next week or early the following week, we should be able to finish up the unit, and then we'll have a day of review. So we're probably looking at about 2 weeks from now having the chapter 3 test. Okay, so just kind of keep that in the back of your mind. Any questions, comments, concerns now before we get started? All right, so factor theorem. If C is a 0, then we know that x minus C has to be a factor of P of x, right? And this kind of goes back to those 4 equivalent statements that we talked about before. Okay, so in this case, as long as C is a 0, then x minus C has to be a factor. And this can also be read in the other direction because it's an if and only if statement. You could read both ways. So you could say if x minus C is a factor, then C has to be a 0. Okay, so again, both of these are equivalent statements. This is going to be useful because if we know that something is a 0 now, then we can list the factor that comes from that 0, and we can use that to help us factor polynomials that are higher degrees than what we've done in the past. All right, so what we want to do here is we want to take this polynomial. We're going to first show that P of 1 is equal to 0, and then we're going to use that to actually completely factor that polynomial, right? Because before, we wouldn't have had a way to factor that with an x cubed in there. It's not 4 terms, so we can't do grouping, right? So we need some other way to factor, and knowing that P of 1 equals 0 is actually going to help us to factor it now. Okay, so first thing we want to do now is think about the fact that P of 1 is equal to 0. Well, that means that 1 is a 0 of the polynomial, as long as we can prove that. How could we show that 1 is a 0 of the polynomial? Yeah, right. So one way we could do it is just substitute the 1 in for x and then make sure that it actually equals 0, right? So that's one way we could do this. Say P of 1 equals 1 cubed minus 7 times 1 plus 6. Okay, so if we simplify this now, 1 cubed is 1. Negative 7 times 1 is a minus 7. And then we add 6. And so if we combine all that now, what are we going to get? 0, right? Okay, so this does give us 0. So that does show now that 1 is a 0 of that polynomial. Now, to actually do the factoring of this, right, since we know that 1 should work, what we're going to do is actually use synthetic division now with the 1 so that we can get this down to a quadratic, something that's x squared, and then go from there. So I'm going to put 1 in my box here. And then we're going to list out the coefficients. Okay, and again, remember, if you're missing a term, we have to put a 0, so there is no x squared this time. So our coefficients are 1, 0, negative 7, and 6. All right, what's our first step with synthetic division now? Bring down the 1. Good. So bring that down. Now we're going to multiply. What's 1 times 1? That gives us 1. And then we add. 0 plus 1 is what? 1. Multiply again. 1 times 1. That's also going to be 1. Negative 7 plus 1 should give us what? Negative 6. And negative 6 times 1 is negative 6. And now if we add those together, what do we get? Zero, right? As long as we get a remainder of 0 here, that tells us that this value in our box is a zero of the polynomial, right? Because that remainder theorem told us that when I substitute 1 in, I should get whatever the remainder is. In this case, the remainder is 0. So that's another way we could have shown this, right? Now, once we've done that, remember this line down here, the 1, 1, negative 6, gives us our coefficients of our new polynomial. So if we've done our division now, what's the exponent going to be on our new polynomial? Squared, right? Okay, so this is going to be 1x squared plus 1x minus 6, right? And if you don't want to put the ones, that's fine. They're understood. Okay, but that's what those numbers become now. All right, so now I know that this is part of the factored form of this original polynomial. And what else has to be a factor now? If 1 is a 0, what has to be a factor? X minus 1. Good. So now I know that x minus 1 is the other factor of this. Now all we have to do is look at the trinomial that's left there and see if we can factor that any further, right? So if we've got x squared plus x minus 6, how would that factor? Good. So we're going to have x plus 3 and x minus 2, because that would give us a positive 3x and a negative 2x. That's the 1x we need in the middle. And then 3 times negative 2 does give us negative 6. This now is the completely factored form of that original polynomial that we started with. Okay. So by knowing one of the zeros and using that then to do synthetic division, we can get it down to a quadratic. And once we have that quadratic, then we can see if that factors further. And if we can, then we have the completely factored form. Okay. Any questions about any of the steps that we did there? All right, and this process is going to keep coming back because as we get into 3.4 and 3.5, we're going to be looking at polynomials of even higher degree, figuring out how do we find those zeros that would work, doing the synthetic division, and then getting it down to something where we can actually factor it all the way out. Okay. All right, example 6, this is the last one from this section. We want to find a polynomial of degree 4 that has zeros of negative 3, 0, 1, and 5. Okay, and then it tells us here the coefficient of our x cubed needs to be negative 6. We're going to deal with that at the end. Okay, so the first thing we want to do is just deal with the fact that we need a polynomial of degree 4 that has zeros of negative 3, 0, 1, and 5. If those are the zeros, what does that tell us? What do we know about this polynomial now? Okay, so let's just go one at a time here. If we know negative 3 is a 0, what does that tell us about the polynomial? That x plus 3 has to be a factor. Good. So I know when I am actually looking at this polynomial now, x plus 3 is one of my factors. What else has to be a factor? Good, just x, right? Because x minus 0 would just be x. So x has to be a factor now. What else has to be a factor? X minus 1. And our last factor would have to be x minus 5. Good. So by knowing the zeros now, I know the factors of that polynomial. And if you look at this, if I multiply all this out now, what's the degree of that polynomial going to be if I were to multiply this out? 4, right? And that's what we're looking for. The polynomial of degree 4, this would give us an x to the 4th. So that's our next step, is we're actually going to multiply all this out to get the polynomial. Okay, so if they give you zeros, you know the factors, then we can list the factors and multiply it to get the polynomial. So I'm going to first distribute the x here. So that's just going to give us x squared plus 3x for that first one. I'm going to go ahead and multiply these two out. So that's going to give us x squared minus 5x minus 1x is negative 6x, and then plus 5. Okay, so I just multiplied the x plus 3 and the x together, and then I multiplied the x minus 1 and the x minus 5 together. Any questions on that step? All right, so now we need to multiply all this, right? And if you want to use your box to do this, you can, because we have 3 terms and 2 terms. Or you can just distribute, whichever one's easier for you. We've got x squared, negative 6x, positive 5. And then over here we've got x squared and 3x. All right, so what's x squared times x squared? Good, that's our x to the 4th. And we can do x squared times negative 6x. Good, negative 6x cubed. Then 5 times x squared would be what? 5x squared, perfect. Go down to the next line, 3x times x squared would be 3x cubed, good. 3x times negative 6x. Good, negative 18x squared. And then finally, 3x times 5 is 15x, perfect. All right, now we just have to combine like terms. Okay, so notice here we've got a couple of x cubed terms we can combine, got a couple of x squared terms we can combine there. That's going to give us x to the 4th. If we combine the x cubes here, negative 6 plus 3 is a negative 3x cubed. Then we have the 5x squared and the negative 18x squared. That's going to give us a negative 13x squared. And then finally the positive 15x. Okay. Any questions on what we've done so far? Okay, now the last step here is we need the coefficient of x cubed to be negative 6. Well, right now, that polynomial has a coefficient of negative 3 for the x cubed term. So we got to think, what could we do here to actually make that a negative 6? Good, right? So we can actually multiply the entire polynomial by 2 because that's not going to change the zeros, right? I can put any a value I want out front, and it won't change the fact that those are still the factors and those are still the zeros. So in this case, it's 2 that I want to multiply by so that I can get that negative 6 in front of the x cubed. We're going to have 2x to the 4th minus 6x cubed minus 26x squared plus 30x. This is our polynomial now. And so it has a degree of 4, has the leading or the coefficient of x cubed that we were looking for, and it would have those zeros, negative 3, 0, 1, and 5. Any questions on that one now? All right, so that's everything from that section. Let's move on to 3.4. Okay, so Callie, the reason we had to multiply by the 2 is because of this piece of information at the end, that the coefficient of x cubed needed to be negative 6. When we first did this, we got a coefficient of x cubed that was negative 3. So we just have to figure out, well, what could we multiply by that would change that -3 to a -6? That's what told me I needed to multiply everything by 2. Because if I go in and multiply that term, I would have to multiply the entire polynomial by that value. Okay. Any other questions there? All right. So let's move on to 3.4 now. All right, so 3.4, real zeros of polynomials. And so what we're going to look at here now is how do we find all the zeros of a polynomial, especially when it has a degree much higher than what we're used to, right? Because so far, most of the stuff we've done has been degree 2, 3, maybe 4 in some cases. So we're going to start looking at some even higher order degrees and figure out how do we find the actual zeros of those polynomials and eventually get them down to factored form also. Okay, so if we have this polynomial, and this is that general form of a polynomial, right, that we've been looking at, has integer coefficients. Okay, so all the coefficients have to be integer values, positive or negative whole numbers, right? Then every rational zero of the polynomial has to be of the form P over Q, where P and Q are found by finding factors of the constant coefficient and the leading coefficient. Okay, so our p-values, we're going to look at the constant. We're going to list out all the factors of the constant. The q-values, we're going to list out all the factors of the leading coefficient. And then we're just going to divide all those values to figure out what are the possible rational zeros. Okay, and remember, rational here means fractional. Okay, so these are the possible fractions that would be zeros. Now, keep in mind, right, 2 over 1 is technically a fraction, so 2 would be a rational zero. And we're going to go back to that synthetic division, right, to test each one of these, because again, this is going to give us a list of possibilities, not necessarily the ones that work. We're going to have to use synthetic division then to test and see which ones actually are zeros. All right, so here's what we want to do. We want to find all the rational zeros of this polynomial now. So first thing we're going to do is list out our p and q values. Let's start with p. So remember, p is the factors of the constant term, right? So this is factors of your constant. So what would be the factors of that constant term now? One and two, right? Okay, so the only things you could multiply to get to would be 1 and 2. So we're going to have 1 and 2. Now, here's the only other thing we have to remember. It could be +1 times +2. That would give us 2. Is there any other combination that we could do to get a +2 here? -1 and -2. And so in this case, we're going to say, well, our factors are actually +1 or -1 and +1 or -2, because some combination of that, right, 2 negatives or 2 positives could give us the +2. These are always going to be plus or minus, okay? Because no matter what that sign is, whether it's positive or negative, we're going to need the positive and negative combinations to get that value, okay? So just always put a plus or minus in front of those factors. Any questions on finding the p-values this time? All right, now, q. This is going to be the factors of our leading coefficient. So what would be the factors of our leading coefficient this time? Okay, good. Just 1, right? So our leading coefficient is 1. That's the only thing that'll work. Now, again, some combination of +1 could give us a 1, or what else could work? -1 times -1, right? So again, we need plus or minus. And again, that's always going to be the case with all of these factors. Always put a plus or minus there. Any questions about how we got the factors of the leading coefficient? All right, now we do P divided by Q. So what we're looking for now is all the different combinations that we could get by dividing each of the P values by each of the Q values. Okay, count the exponents of the factors. No, so in this case, right, the exponent makes no difference whatsoever. We're just looking at the constant term, which is the one that doesn't have any variable, and we're looking at the leading coefficient, which is the coefficient of your highest degree, right? So that's all you're looking at are those numbers. The exponent itself makes no difference. Is that your question, Destry? Okay. All right, so now if we divide P by Q, again, we're dividing every single P value by every single Q value. So I'm going to do this first off, right, just very meticulously going through one by one, and then I'll kind of show you there's a little shortcut, right, where it doesn't take so long. But in this case, I have a +1 and I have a +1, right? So one of my possibilities would be 1 divided by 1. That would give me 1. So that's one of my P over Q values. I could also take the -1 and divide it by the +1. So that's going to give us -1. And then I'm going to go to the +2. I could take the +2 and divide it by 1, and that's going to give us 2. I could also take the -2 and divide it by the 1, and that's going to give us -2. Now, that only takes care of dividing all 4 of the original P values by the +1 of the Q's, right? Now, there's still dividing all 4 of the P's by the -1 instead. Well, if I do that, we're going to have 1 divided by -1. That's -1. Then we're going to have -1 divided by -1. That's +1. Then we'll have 2 divided by -1. That's -2. And we'll have 2 divided by, or sorry, -2 divided by -1. It's going to give us +2. So there's technically 8 combinations here, right? Because we have 4 P values, we have 2 Q values. So that's going to give us 8 different combinations of what we could divide. But looking at our list now, what are the actual only values that we get? Yeah, positive and -1 and positive and -2, right? So our list here is really just ±1 and ±2. The easy way to do this is just to say, well, 1 divided by 1 is 1, and because they're both plus or minus, we know it's going to be a ±1. 2 divided by 1 is 2, and because they're both plus or minus, we know it's going to have a plus or minus. So that gives us our P over Q value. So you don't actually have to go through every single possible combination, right? We can just do this value divided by this value and put a plus or minus, and then the 2 divided by the 1, and then put a plus or minus. Okay? Any questions about how we got those P over Q values now? So it'll be the same thing when we have more values for Q. You'll still just divide the numbers themselves and then always just put a plus or minus in front, right? So that's what I was kind of saying is you don't have to worry about every single possible combination because we know the plus and minuses are going to take care of themselves. So you're just going to divide 1 by everything in the Q list, 2 by everything in the Q list, and then just put plus or minus in front of all of them, okay? All right, and we'll do more examples, obviously, that have even more P and Q values so we can see what those lists look like. All right, now that means that we have 4 possibilities for the rational zeros of this polynomial. So now what we're going to do is we're actually going to test to see which ones of these 4 actually work. I'm going to start with the +1, and the way we're going to test is we're going to use synthetic division. put positive 1 in my box. I'm going to list out all of my coefficients here. So we have 1. We're missing the x squared term, so that's a 0. We have a negative 3, and we have a positive 2. First step, bring down the 1. Then we multiply. 1 times 1 is 1. Now we add. 0 plus 1 is 1. 1 times 1 is 1. Negative 3 plus 1, negative 2. Negative 2 times 1 is negative 2. And so what are we going to get as the remainder this time? 0. So what does that tell us then about 1 in this case? It is a 0, right? Because if we get a remainder of 0, that means the number in the box is a 0 of our polynomial. So this one right here actually works. So when I come down here and list out the actual zeros now, I know that 1 is one of those zeros. Now we're going to do the same thing with the other 3, right? So negative 1's the next one I'm going to check. Get my coefficients here. 1, 0, negative 3, and 2. Bring down the 1. This time 1 times negative 1 is negative 1. So when we add, we get negative 1. Negative 1 times negative 1 is positive 1. That's going to give us negative 3 plus 1 is negative 2. Negative 2 times negative 1 is positive 2. And so what's our remainder this time? 4, right? So what does that tell us about negative 1 then? Not a 0, right? So this one right here does not work. So in all cases, we're looking for that remainder to be 0. As long as it's 0, we know it's a 0 of the polynomial. If we don't get a remainder of 0, then we know it's not. All right, let's check the next two now because we have positive 2. Again, our coefficients are the same. All right, bring down your 1. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. Negative 3 plus 4 is 1. 1 times 2 is 2. And so what's our remainder this time? It's going to give us 4. So what does that tell us? Good, not a 0 this time. Right? All right, we've got one more to check now, the negative 2. Put that in my box. 1, 0, negative 3, and 2 again. Bring down the 1. 1 times negative 2 is negative 2. 0 plus negative 2, negative 2. Negative 2 times negative 2 is positive 4. Negative 3 plus 4, positive 1. And 1 times negative 2 is negative 2. So what's our remainder this time? 0. And so what do we know now? Good. Negative 2 is a 0. And so again, I'm going to add that to my list. So now in terms of finding all the rational zeros of this polynomial, these are the rational zeros for that polynomial that we started with. Now, keep in mind, that's not to say that these are the only zeros, right? In this case, they are, but these are the rational zeros, but we could also have irrational zeros down the road. So we just have to keep that in mind that not all zeros are going to be rational. But again, what this is useful for is this will get us down to something normally that we can at least factor, right? Or use quadratic formula if they happen to be irrational. So we can find at least a couple zeros that work. Then we can get it down to something that's more manageable. Any questions on this one now? Okay. Now, here's what I'm going to show you. I'm going to switch over to Desmos real quick. I'm going to graph this function. you'll see that graphing is very helpful in a lot of cases, and we're actually going to use it a lot throughout this section and the next section. Okay, so our original function here was x cubed minus 3x plus 2. And so if you look at the graph here, you can pretty easily see -2 is a 0, and that's what we found. And then you can see here that 1 is also a 0. And in this case, what could we probably say about the 1? Okay, it is a minimum. I agree with that, right? But think about the fact here, right, that it doesn't pass through the x-axis at that point. It bounces there. So what does that tell us about that 0? Good. It happens multiple times. Specifically, if it bounces, it happens an even number of times, right? So we know that this one would have to happen 2 times or 4 times or 6 times or something like that. And again, that's going to be useful when we're actually doing our synthetic division, because sometimes you'll have to recognize, oh yeah, it bounces there. I might need to do my synthetic division with that one multiple times to make sure I can get it down to what I need to, okay? So just keep in mind, when it bounces, it has an even multiplicity. If it passes through, it has an odd multiplicity instead. Okay. All right. Example 2. So now we want to write a polynomial in factored form and find all the zeros. Okay, so we have another cubic here, 2x cubed. We're trying to get this into factored form and find all the zeros. Okay, so our first step again is going to be to find those possible rational zeros. So we're going to do our p and q values again. Okay, so what are the values for p going to be this time? Good, right? So our factors of 6 are either 1 and 6 or 2 and 3. And like I said before, always put plus or minus. Good. So we're going to have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Those are all the factors of 6. All right. Now let's look at our Q values. What are the factors of the 2 now, the leading coefficient? Yeah, this time plus or minus 1 and plus or minus 2. Okay. Any questions about how we got the P and Q values here? All right, now we need to do P divided by Q. So we got to do every combination here. So I'm just going to start with the 1 and the 1. So if I divide those, what am I going to get? Good, so plus or minus 1. Then we're going to do 2 divided by 1, so that's going to give us plus or minus 2. 3 divided by 1 is going to give us plus or minus 3. And 6 divided by 1 is plus or minus 6. Now we have to take all the p-values and divide by the 2. So if I do that, what's that first one going to be? 1/2. Good. Then we're going to take the 2 divided by 2. That's going to give us what? 1. We already have 1 on our list, so we don't need to list it again. Okay, so just keep that in mind. There's no point in repeating these values. All right, the next one we've got is 3 divided by 2, so that's going to give us what? 3/2. Good. And then finally, 6 divided by 2 would be what? 3. But again, we've already got 3 on our list. I don't need to list it again. Okay, so this is now my list of P over Q's. These are the possible rational zeros of that polynomial. Any questions about how we got that list? All right. How many options do we have this time? Can I do that part again? Sure. So basically, I'm just taking each one of these values from my P list, and I'm dividing by 1 first, right? So that's going to be 1 over 1 is 1, 2 over 1 is 2, 3 over 1 is 3, and 6 over 1 is 6. And again, because they all have plus or minus, that's why I put plus or minus in front of all of them, right? So that takes care of all of these right here. Then I'm going to take all of those p-values and divide them by the 2 instead. So that's going to be 1 over 2 is 1/2. 2 over 2 is 1, but we already had that one. 3 over 2 is just 3/2. And 6 over 2 is 3. And again, we already had a 3 from the previous one, okay? So that's how I got these 2 additional ones, or technically 4 additional ones, because they're both plus or minus. Any other questions there about getting that list? Okay, now once we have that list, here's what I'm thinking about. How many options do we have for rational zeros this time? There's 12, right? Okay, because we got 6 values and they're all plus or minus, right? So 6 times 2 is 12. I don't want to do synthetic division 12 times with that polynomial to see which ones of these actually work, okay? So what I'm going to tell you is you've got access to Desmos. I would use the graph at this point to see which ones look like they work, and then I would just focus my synthetic division on those, okay? So that's what I'm going to do next. I'm going to graph this. We'll figure out which ones we think we might want to use, and then we'll just do our synthetic division on those values, okay? All right, so this time we've got 2x cubed plus x squared minus 13x plus 6. All right, so looking at that graph now, what values look like they might be zeros? Okay, so it looks like -3, right? So we have a value right there between -2 and -4. So that's one we probably want to check. What else looks like it might work? Okay, yeah, 1/2, right? Because if you look at the graph, I can zoom in if I need to here, right? This value right here is 1, and so you can see that it looks like it's crossing somewhere between 0 and 1. So 1/2 is another value we probably want to check. And then finally, what's the last? Yeah, it looks like 2 there, right? So those are the 3 values we probably want to check this time. And again, even if you're using a graphing calculator, usually you can see close enough on the graphing calculator to say, oh yeah, these are the values I probably want to do synthetic division with. Like the 6 and the -6, there's no point, right? Because you can definitely see it doesn't cross there. So this at least narrows us down so we don't have to check all 12. Okay? All right, so let me go back to the notes now. We'll actually go through and check these. All right, so we'll start with the -3. Again, we're going to use our coefficients from the original polynomial. So that's 2, 1, -13, and 6. No missing terms this time. First step, bring down the 2. And we multiply. So 2 times -3 is going to give us what? Good, -6. 1 plus -6 is going to be what? -5. Good. -5 times -3. 15. -13 plus 15 is 2. 2 times negative 3, negative 6. Good. Now, that means our remainder is going to be what? Good. So we get a remainder of 0. That tells us negative 3 is a 0. So in terms of my list of actual zeros now, I know that negative 3 is one of them. All right. Now, what I'm going to tell you is we can actually, once we find one that works, we can continue our synthetic division on the line that we've got there now. Because if this worked, then I know that this line down here is part of my polynomial. It's going to be a factor of it. So now I can check my next value, the 1/2, and I can just continue on from this line right here. And again, this is going to be useful because then we can actually get this down to the completely factored form if we don't keep going back to the original every time. Okay. All right. So again, bring down the 2. What's 2 times 1/2? It's going to be 1. Negative 5 plus 1 is what? Negative 4. And negative 4 times 1/2 is negative 2. Good. Remainder here is going to be what? 0 again. And so that tells us, because we got a remainder of 0, that 1/2 works. So 1/2 is one of our zeros. Now, here's what I want you to think about. What does that line at the bottom now represent? So think about where we started, what our original polynomial was. We've done synthetic division twice now. So what does the 2 and the negative 4 tell us? Two x minus 4 is a factor. Good, right? Because in this case, if we started with x cubed, we did our synthetic division once, that got us down to x squared. Then we did it again. Now we're down to just an x to the first power. Okay, so 2x minus 4 is a factor. What else is going to be a factor here? So not 0, right? Because if you notice here, 0 was not a possibility on our list of possible zeros, right? Okay, so the negative 3 and the 1/2 are zeros. So what would be the factors from those? So I don't want to go back to the 2x squared minus 5x plus 2, right? Because I've already factored out or divided out one of my zeros from that one to get down to 2x minus 4. So I just want to think about now, I know the other 2 zeros, so what have to be factors in this case? If negative 3 is a 0, what's a factor? Okay, so not x minus 3, but x plus 3, right? So we know that x plus 3 has to be a factor because of the negative 3, and we know that x minus 1/2 would be a factor because 1/2 was a 0. Any questions about how I knew that now? All right, now the last thing is, yeah, so I know down here now, so let me back up just a little bit. I'm trying to see where's going to be the best place to do this. I don't want to erase that. So if I think about this line right here, okay, I know once I've done my synthetic division once, I should go from an x cubed down to an x squared, right? Well, I know that negative 3 is a 0, which means that x plus 3 must be a factor. And then what's left in that boxed in space there is 2x squared minus 5x plus 2. Now, technically, we could just factor that because it's a quadratic now. And so this would just give us x plus 3. And then these factors here would be 2x and x, and then we would need a 2 and a 1, and then we would need two negatives, right, to give us the positive 2, but also give us a negative 5x in the middle. Now, you might be saying, well, wait a minute, those aren't the factors that we actually got, okay? If you notice here with these factors that we got, there's a common factor of 2 in this first one, so I could actually bring that out. And we would get this right here. And if I redistribute that into this set down here now, that's where I'm going to get this, right? Because 2 times x would be the 2x, and then 2 times negative 1/2 would give us the negative 1. Okay, but we can actually just go through and say, well, I know negative 3 worked, and then if I can show that 1/2 works, now I know I'm down to something that's linear, right, x to the first power, instead of something that's quadratic like x squared. So you got two options, right? Either continue your synthetic division until you get down to just a single line with two values, or if you get it down to something that's quadratic, you could actually factor at that point and actually do it this way. And either way, you're going to get the completely factored form, and in this case, the 2 is going to be your last 0. Okay. So Emma, did I just confuse things even more? Okay. Yeah, so I know it's a lot, right, to think about, but in this case, right, just think you're starting with x cubed. We know in this case that every time I do synthetic division, it's removing one of those x's, right? So each one is going down to x squared and then x to the first power. So in this case, because I did my synthetic division twice, I know that this line, the 2x minus, or the 2 and the negative 4, represents a 2x to the first power minus 4. The benefit of doing it the way I did it down here where I started is you don't have to worry about that common factor of 2, right? Because whenever you do fractions, we're never going to have fractions within a factor. And so the factor that you actually want to use to get 1/2 is 2x minus 1 instead. So I think, start with your integer values is one thing I would always suggest, because that kind of helps. And then once we get it down to something where we can factor where it's quadratic, it's probably best to go ahead and factor at that point rather than trying to test fractional values, okay? Because a lot of people want to stop right here, but we don't really like leaving fractional values in our factors, especially when there's a common factor in one of our other factors, okay? Yeah, so in general, right, get it down to something that's quadratic and then see if you can factor it. Any other questions here now? And that's it, right? Because we were asked to find the zeros. So there's all the zeros. And we were asked to find the factored form. This would be the most simplified factored form of that one now. All right, so that's where we're going to stop for today. Again, the homework I pushed to Monday, and again, you can at least go ahead and get started on the 3.4 stuff, because most of it is finding these zeros, right, which you can use Desmos to do. You can check with synthetic division, because that's what I'm going to ask for on the test. So just make sure you're comfortable doing that. We'll finish up 3.4 on Monday, and that homework will be due. And again, just a couple weeks from now is probably when the next test is going to be, so just kind of keep that in mind, okay? Let me know if you got any questions. Have a great weekend, and I will see you all on Monday.